Right, good morning everyone. My name is Ben and I'm the Training Manager here at 3D Scanners. You'll have already seen this morning in Gajeevan's presentation essentially the release of the ribbon, the new user interface for 2024. I will now be going through essentially the new functionalities and user improvements for the software. So feature requests, some of you may already be familiar with the term. Feature requests are essentially customer-driven sort of improvements. Since 2019, you'll see on the screen that there have been 10,000 plus feature requests. So that's people like yourselves, either emailing us or emailing Infometric directly and asking for certain improvements or new features in the software. 400 of those have been implemented in that same time frame. So like I said, it is completely customer-driven. Customer feedback is essential to these improvements and enhancements. So please keep using the software, keep pressing buttons, keep telling us how to improve it because it is beneficial to us and yourselves as well. My presentation today is effectively going through some of those feature requests that have been implemented in PolyWorks 2024. Some of them have been asked for a few years now that they're finally here. So starting off with, this is quite a small one to start with really. Essentially standard piece and project properties, so just skipping on. Essentially in 2023 and previously, in your sort of project browser as it was updated recently, you were able to you've not been able to remove standardized piece properties. So, there's many different customers in here, many different companies. You will not all have the same standardized properties. So it is now beneficial that you can remove these. So these are your project properties and these are your piece properties as well. So moving forward to PolyWorks 2024, you'll see on the right-hand side of the screen, some of those properties are now removable. Okay. One thing to note with that is if you do essentially bring them back in with the same names, all of your links in your reports will work. So if you do accidentally delete anything, don't worry, it will just come back in if you name it the same. So they're the project properties in 24, and then the same with the piece properties as well. So that's previously, and now you'll see again, you are able to delete those. In the piece properties tab, you'll notice that there are still 4 remaining. Those ones still cannot be deleted because they're imperative to the sort of functionality of the software in the background. Sorry, I pressed the wrong buttons. Yeah, so just a minor sort of update, but anyone that's sort of been in training sort of the last couple of years, we do sort of encourage you to sort of fill these out sort of every time you create a project, every time you sort of run a new piece. These are essential if you are looking at using data loop in the future or if you do have data loop currently. Perfect for traceability and even searching for projects and sort of parts and anything like that as well. So yeah, we do encourage you to fill these out as often as you can. My next topic, as you see on the screen, probing fit parameters. Those of you that have scanning devices may already be familiar with the sort of fit methods and the extraction methods. So you'll see on the screen we have a circle on the left-hand side, which is a best fit extraction, and a circle on the right, which is a minimum fit extraction. So the ability to effectively simulate sort of assemblies and sort of constraints as well. So you just about make it out underneath the circle here. You've got sort of constraints. So you can constrain the radius and the center of the circle in this case. Effectively, the point of this part of the presentation is that this is now possible for probing. So not only manual probing, but also CNC, CMM probing as well. Okay, so just a short video to play you to sort of demonstrate this.
When inspecting parts, assemblies, and fixtures, fitting methods for measured data points can be used as quality control, analysis, and problem-solving tools. With PolyWorks Inspector 2024, you are in full command of the fitting parameters for probed features. You can predefine the fit type to determine minimum or maximum mating feature size. You can constrain the feature size before probing the location of precision components like tooling balls. Constrain center points to ensure concentricity with reference geometry. Like all probing parameters, fitting methods and constraints can be modified after probing. The measurement results are automatically updated, saving you time and giving you flexibility. Gain complete control and flexibility over fitting parameters during probing.
One thing to add to the end of that wasn't included in the slides or the video, with it being the fit of the probe points as well, it is imperative that you use more than the bare minimum of points as well, whether that was an assumption. My third topic today, so the third of 5 that I'm going to go through with you. Control views. How many people in this room use control views or know what they are? Big hands up. Okay, so I just mentioned before about piece properties and project properties. Imperative if you're looking at using data loop or currently use data loop. Control views sort of fall under the same category. How many of you use PolyWorks for reporting? Okay. How many of you use control views with your reporting? How many use basic snapshots and tables? So sort of more towards that. So in, well, sort of training and sort of years gone by, that is how we would have shown it you. Essentially, basic snapshots and tables were the way forward at the time. So you'll be familiar with, for example, on the left-hand side, again, we've got a circle that's using a best fit alignment, and then on the right, we've got a date and reference frame. So basic snapshots and tables, you could essentially report 2 at the same time. So you'd have a snapshot and a table for your best fit and a snapshot and table for your DRF. Now, just to sort of highlight that, you could do the same with your color maps as well. So it's not only features and objects, you could also do the same thing with your color maps as well. As I said, so historically, your report items, when they've been created, whether that goes straight into the formatted report or into the tree view, you were able to access the properties of those items and change the context of that particular image. So you can go into the actual image in the report or from the tree view itself and change the controls, as you can see by the 2 images on the left-hand side. Previously, until this year, control views, which I'll explain sort of more about them in a second, control views weren't really possible to do that. As you can see, the boxes are sort of set. If you're not familiar with control views in PolyWorks, they're sort of designed to replicate what you would see on a drawing, so your drawing views. Okay, so I'll be showing you in a second how we can actually create those. Sort of in the last 18 months, 2 years, if you have been on a PolyWorks training course, we would encourage you to use control views instead of sort of your basic snapshots and tables, again, for the purpose of taking that into data loop in the future. Okay, so historically, control views, so this is the control reviewer. Essentially, what you can do, though, is you can edit the context of these controls. So the little highlighted icon there, you can see, for example, circle 1, currently the coordinate system for the diameter X, Y, and Z has been set to sort of DRFA. So this is how you did it previously. You would have to go into the control reviewer and set the context of these controls. The limitation of that, however, was that you then couldn't report that differently. It would, no matter how many sort of tables and snapshots you created, it would always read the same control, the same coordinate system and/or alignment if you'd specified. What is now different in PolyWorks 2024 is you can have as many control views as you like, and you will be able to change the context of those control views, which I will show you in a second. Perfect. So moving into 2024, so hopefully this will become more familiar to you throughout the day, the sort of visual changes that it sort of has taken on board. The first thing that you may notice, so we have a part here, we've just got some comparison points on view. The first thing that you may notice is now in the top left corner of the 3D scene, you now have an annotation specific to what alignment and what coordinate system is currently active in that project at the time. Now, this works as a sort of typical annotation, so you can move it around just by sort of hovering over it and dragging. You can reposition it quickly back to the top corner as well, just by unlocking it. And in the same way as a normal annotation, you can edit it with the spanner icon as well. You'll see at the top here, we do still have table and snapshot available. So if I just take a quick snapshot, that will automatically populate the report for us. You will see now at the top, there is no need anymore to use your sort of basic text boxes and tell the reader of that report what they're actually looking at. The actual caption there is going to be there moving forward. Like I said, you can move it and do whatever you need to do with it as well. So that will quickly identify what alignment, what coordinate system you've been using. It is possible to turn it off. If I flip back to the 3D scene, in the View tab now, you can go to the Utilities drop-down, and it is possible to turn it off should you not wish for it to be there. Now, from the hands that went up, most of you sort of are familiar with the table and the snapshot. If you haven't used it in 2023, don't worry where it was, because you will now see that in 2024, it is still part of the Review tab. So we have the Control Reviewer. which essentially is a long list of all the different controls and objects that you've created in this project. And we also have next to it as well, we also have what's called create from 3D scene. So this is how we'd encourage you to create these control views. Position your 3D scene how you want it to sort of appear in the report like you normally would with a snapshot. When you then click on create from 3D scene, what this will allow you to do is essentially name your control view, describe it if you wish, and then you can also now, in the drop-down, the first drop-down, you can now control the context of that control view. So this is effectively the same now as when you went into your snapshot and tables and changed the context for the properties. So if I set that to DRF ABC, so I'll just add that to my description as well. So DRF. If I now hit create, effectively in my report, because of how this is set up, you will now see at the bottom of the report, we now have an image, specifying ABC, and also the table as well. Now previously, if I now create another control view and try and assign that to a best fit, so if I show you the tree, if I try to create another control view to report those objects in a different alignment and coordinate system, that wasn't possible before, because as you sort of remember from the presentation, the three icons I had on the screen, the three images, the one on the very right, it wouldn't allow you to change the context of the alignment or the coordinate system. That is now possible. So if I show you the drop down here, first of all, you'll see some existing control views have been created in this project. The ones with the sort of tooltip here indicate that a specific coordinate system or alignment have been chosen. Okay. So just to show you, if we go back to the 3D scene again, and again hit create from 3D scene, this time this one will be best fit. And then the same from the drop down too. So best fit reference 1, hit create. And if I flick back to my report, you will now see that the second one, so we now have best fit. Previously this wasn't possible, but it is now going forward. So like I said at the beginning, we would encourage you to use control views as often as possible, mainly for the purposes of data loop. Within data loop, you can access these control views sort of, either on your laptops, PCs, and again, it was shown, I think it was shown in the first presentation, you can now use data loop on your, I don't know if it was on your phone as well. So it's at your fingertips whenever you need it. And it essentially appears how you see it on here as well. So all of your control views listed, and this is how you would see them in the data loop web interface as well. Cool. Just to finish this topic, there are some sort of more in-depth sort of features to this, but this is essentially the highlight of what you can do. If anyone has any more questions about this, please come and see me afterwards, because like I said, there is a bit more sort of information to this as well. Perfect. Right, my penultimate topic this morning is datum surfaces. Now, not possible in PolyWorks before 2024. I believe our colleagues in Canada have sort of informed us that there's been 250 feature requests for datum surfaces, and I'm pleased to announce that it is finally within PolyWorks 2024. So if anyone was here last year, you may remember I did a presentation on custom degrees of freedom. I actually ended up throwing a coordinate system at someone from the audience who I've actually noticed isn't here today, so whether he taught that personally, I'm not sure. But yeah, essentially 6 degrees of freedom. It's essentially controlling how your part is aligned and controlled. So you've got your 3 translational degree, sort of constraints, and then your rotational ones as well. If you're familiar with either the ASME or ISO standards, you'll see at the bottom of both that complex surfaces are included in the standards, so it's sort of about time that they're included in Inspector as well. And then this isn't a gimmick, this is just a screenshot. As you can see, Surface Datum A, it is now possible to add this into the Inspector as well. So I'll be going through how we can set this up in a second. 2 methods for this, so sort of enlarged on the right-hand side, datum surface computation. The top one is use mobility within the surface profile tolerance zone, so effectively controlling the position of the surface within a specified tolerance zone. And the second one, align with outside material constraint, essentially assumes sort of a max fit, which using custom degrees of freedom, you can sort of dictate as well, let's call it. So just to explain those 2 options in sort of visual form, just to make them make more sense. The first one, so use mobility within surface profile tolerance zone. You will see we've got the sort of solid green line. That's our sort of CAD model. That's our nominal surface. We then have our surface profile tolerance zone, which is essentially the hashed green line as well. The way that this works is if you use the first of the two options, the actual measured surface, so the black line, can fall anywhere within the sort of profile zone itself. Okay. So you will see, looking at the line, we do have some crossover, so this will sort of give you interference in the sort of part as well, which I'll demonstrate in a second with the colour map. Okay, the second one, align with outside material constraint. So again, just turning on our, so you'll see to start with, it effectively performs like a max fit. You will see that the position of the hole is some way off, sort of retrospectively. So what you're able to do is specify degrees of freedom, so your own custom degrees of freedom, which effectively keep the contact the same, but allow you to translate in the degrees of freedom that you haven't clocked off. So effectively that sort of procedure there. So I'll be showing you this now, how to actually set this up as well. Okay, so back into PolyWorks 2024. So again, just sort of getting used to the new interface. So to create features now, you're in the Home tab, and then we have our surface feature here. So for those of you that aren't aware, surface features can't be created from the actual CAD model themselves, so we need to do some manual selection. So pressing the spacebar. As Kajiva mentioned earlier, the select element sort of options are now at the bottom of the 3D scene rather than the dialog zone. So I'm just going to choose this face here. And then this wasn't possible before, so the datum feature label is now possible for surfaces. So datum surface A, create that. I'm just going to remove the controls, just put that there for a second. So again, right-click menus have been shortened, so my geometry controls are still in there. I'm just going to take away these for now. Perfect, so I'm just going to extract, so there is already a scan in here, so I'm just going to extract these quickly. Perfect, and then, so going back to the presentation, there was a call out of position, so I'm going to use this datum pattern here. So for example, I'm going to jump into datum pattern B. Within my geometry controls, I can add GD&T, and I can add position relative to now datum surface A. Okay, there is an error there, but this is all by design, just to show you how it works. The good thing about PolyWorks is that a lot of the errors that you will see, they're pretty good at explaining what the problem is. So you'll see there that the datum surfaces using profile tolerance, tolerance zone mobility must have at least one valid surface profile. So obviously I've not applied that just yet. So if we jump into the datum surface A, again into the geometry controls, I can add a surface profile. Okay, perfect, so that's all we need. Jump back to B, and again, you'll still notice that there's no measured value there for the position. Based on the first setting that we're using, and I'll show you what that is shortly, for this to be able to work, the actual measured surface needs to have the ability to move and rotate within that profile tolerance zone. So if we jump back to surface A, you will see that the measured value is more than the tolerance. So it's not possible for it to actually move and sort of rotate within those green dashed lines we saw previously. So if I increase this tolerance to sort of anything larger than that, so if we go with 5, if you look at the annotation in the middle of the screen, you'll now see that we have a reading for position to datum A. So using the first sort of option, so the options have now moved, they are now in the File tab, so File Options. I'm going to be jumping in here quite a bit in the next few minutes, so if I right-click on it, I can say Add to Quick Access Toolbar. So that will then appear at the top for me. So I'm going to jump into here. And these are our GD&T settings. So they're in the Objects, Features, and GD&T. This search bar now has been around for a while, so if you're not sure where they are, just use that. Near the bottom, we have our datum surface computation. And again, the one we're using currently is use mobility within the surface profile tolerance zone. So as I said, we need that tolerance to be big enough for it to actually do that. So what I'm going to do is just align by that to show you. So if we align using datum reference frame to datum A, and then what I'm going to do is just to show you the interference of how that actually works, I'm just going to create a quick color map. So if I jump to, where are we, datum surface A, so if I right click, I can select the measured data points used for that surface. So you can see that on the screen as well. And I'm also going to select the nominal surface component as well. So if I jump into the new contextual menu of feature and go to elements, I can select the nominal elements of that surface as well. So it's a direct comparison using a color map between the nominal surface and the elements from that scan. So if I jump into the Home tab, color maps are now here, and you'll see that it defaults to selected elements. So if I then hit measure, you will see, looking at the values on the color scale, we have that interference. So if you think back to the illustration on the PowerPoint, because of the fact it's allowed to rotate within that profile tolerance, it can be above and below that surface, which is shown on the screen at the moment. Okay, I've got 2 more of these to show you, so bear with me. So I'm just going to reset the project quickly. So if we just delete that sort of alignment. Jumping back into my options, I'm now going to show you the align with outside material constraint. So effectively performing like a max fit against the nominal surface. So if I click apply and OK. So you'll see if you're looking at the annotation, as soon as I've done that, the measured value for the position disappears. The reason behind that, again, if you use the sort of tooltips, a BSC modifier is required. So I can add that on sort of from the drop down and apply that there. So yeah, perfect. So all working again now. So again, use the tooltips. To show you the custom degrees of freedom setting, what I'm going to do is circle free at the top here. I'm going to add a position to that. So if I assign that datum A, I say this time the BSC modifier is there automatically for us. If I also align it to B as well, so set the DRF to A and B, we don't have an error this time, so the yellow triangle indicates a warning. So the way that this works is the A BSC modifier effectively aligns the surface in all 6 degrees of freedom. What the warning is telling me is that as I've included datum B is pointless at this case, it's not actually doing anything. So A is controlling all degrees of freedom. For B to actually become useful in this scenario, if I click on the drop down, I can enable custom degrees of freedom, specify my coordinate system for that, and then you'll see I'm given the options to essentially define those custom degrees of freedom. So in this case here, datum A locks the translation in Y and also the rotation around X and Z. If I do the same for datum B, so effectively fill the remaining boxes in. So if I had a tertiary datum, I could obviously add that in as well, and you'll see we now get a reading for this. Perfect. So just to finish off this little bit, if I go to align again, datum reference frame, and align to the ABSC. If you look at the colour scale this time, there is no interference, so you'll see that all the values of that colour scale, if I actually show it you, all of the values on that colour scale are now below the surface, indicating the max fit. Okay. Finally, just to show you the 2 different standards, so obviously being in a Canadian software, it's defaulted to ASME. If we switch over to ISO and click apply, and OK, so just bear with me a second while I reset this. Remove these tolerances. So ASME and ISO work slightly differently. ASME, as you've just seen, is to do with custom degrees of freedom based on axes, rotation and translation. ISO standard is what uses situation features. Okay, so if I were to apply that to circle 3, so now I'm in ISO, if I apply datum A, you will see now instead of custom degrees of freedom, you now have what are called situation features. Okay, so to be able to make this work, what I would need to do is if I choose plane, for example, from A, so effectively acts as a plane, we get an error because essentially what I've done is I've not told it what plane we're going to use. Okay, so jumping back into the Home tab, selecting a plane and just applying that to our CAD. You can then jump into the surface, the actual properties, so you can either double click or right click properties. And then on the feature tab page in control, we now have the ability to apply a situation feature for that. So if I just choose plane 1, apply, and then you see we have a reading now for circle 3. Okay. So that sort of brings us to an end of the datum surfaces. Any questions on that, again, come and see me after. Yeah. Perfect. So okay, just before I finish off, I'm not going to read them all out. There are a lot on the screen, but there are some limitations to that. Again, I'm not going to read them all out, but there are some on there. I say sort of highlights of it. Surface features can only be used as a primary datum in PolyWorks. I don't know if there's any plans to change that. And yeah, so that's probably the highlight on there. But again, any questions, please come and see me afterwards or any of the 3D Scanners team.
Except me.
Cool. My final topic today, so we've seen already, so in Toby's presentation, for example, he spoke about the MTC using CNC CMM with PolyWorks. One of his slides demonstrated the ability to scan the fixture and sort of use that as collision detection. So one of the things that PolyWorks has been slightly poor at in the last few years is being able to measure on the CNC CMM without CAD. So essentially what we now have is something called Teach Mode, which I'll be going in to show you shortly. So PolyWorks is a CAD-based software. The sequencing for the CNC CMM is built around CAD for efficiency, so your collision detections, your sort of optimization, if anyone's used the optimal sequence creation tools. But the main thing there is at the bottom, not everyone in this room, unfortunately, has access to a CAD model. So the ways that you've had to do that in PolyWorks in the past, you've had to do it numerically, so sort of key in your features, which can take time, and human error can lead to sort of misinputs as well. Semi-auto, which isn't actually available in PolyWorks, so I'm not really going to go into it. And then we now have Teach Mode. So Teach Mode has been around for many years. It's not only for metrology, but for sort of machine and processes as well. So you teach the machine where you want it to go. Now available in PolyWorks, and the bit at the end there is it has actually been around for a few months now. So if anyone has already had a play around with it, come and speak to us, let us know what you think, any feedback. So as you can see, it's been around since sort of mid-2023 IR7. And this next video is going to show you effectively what you can now do with it before I sort of wrap up.
PolyWorks Inspector 2024 brings ease of use and no-code CMM programming to multi-piece inspections without CAD models. Measurement planning starts with Teach Mode, recording all the information from the first piece measurement. When measuring features, all manually probed points and intermediate go-to positions are recorded. You can directly probe points on surfaces for lengths or distances. The process remains flexible, allowing you to distribute points evenly or customize other measurement parameters. In subsequent piece measurements, all objects will be probed in an automated sequence that suits your needs. To complete your inspection project, simply key in nominal values and create your report, and benefit from viewing your results in 3D using control views. Experience PolyWorks' effortless efficiency in your CMM measurements with or without CAD. PolyWorks.
Perfect. So Teach Mode I've already mentioned, now possible from the sequence editor. So any of you that have used the CMM may have sort of used the recording functionality. That is now where you'll find Teach Mode. So you open up the sequence editor and you'll see in the drop down to the black square at the top, which is normally the red record button, you will now see there's an option for Teach Mode for CNC CMM. So any manual points that you take will be converted to CNC. Okay. So as you can see by the image, sort of when enabled, objects created using the probe will become sort of CNC, so you'll be able to see the measurement path on the screen as well. Yeah, so like I said, once you've actually measured it as a manual probe, it will be added into the sequence, so you can see there step 13, created as a CNC probe method. Okay, any go-tos are also added as well, so whether that's actually in the object itself, so in the feature. So for example, if you're measuring a plane and you need to jump over a clamp, that will be included in these steps as well, or whether you just need to take a go-to position outside of the object itself. Regular users of CNC CMM with PolyWorks will be familiar with the clearance distances, both before and after use or after measurements. That is something that isn't actually active with this, so you will need to be careful with your go-to positions and any safety clearances as well. So that isn't automatically included straight away. The go-to positions can be edited either from the actual sequence itself, or they can be edited from the measurement points pane that you'll find in your measurement properties. Okay. Yeah, as I said, go-to positions useful for obstacle clearance, but please be aware when you're using the Teach Mode, collision detection not turned on, not possible. So please be careful. However, it does. The last point there is that it does still work as normal with your working volume and your table as well. So that will still be possible. Once you've taken those measurement points, so once you've actually gone around and manually probe your CNC sequence, it is possible to then edit those points afterwards. So you can go back into the properties, it will know how many points you've taken and set that as default. You can change it from tactile to tactile scanning. One thing to be careful of that, the last point at the bottom, when you tactile, if you change it for circles and cylinders, it'll be fine because it's a known shape. If you've manually gone around and probed, let's say 10 points for a plane, if you change that to tactile, PolyWorks isn't aware that you've jumped over anything, so please be careful if you do change it from manual from tactile to tactile scanning. Just sort of to finish off, once you've done all that, so they will still be measurements, so it will just be a measured sequence. If you want to do any comparisons, you can either key your nominals into the geometry controls. If you require any of the 3 bullet points at the bottom, so if you require datum features, if you require any GD&T, excluding form, and if you need to perform a best fit measurement objects alignment, you will need to actually create those nominals. So that is still, so essentially that is, before teach mode, you could have used a numerical method anyway. For certain applications, like the GD&T, like the datum features, you will still need to do that. Okay, so the teach mode is essentially just speeding up your sort of creation of CNC programming without CAD in PolyWorks. Okay. And that's all from me. Yeah, thank you very much for listening. If anyone's got any questions, please come and see me any time throughout the day. I will now pass you over to Victor from Careerform. So, yeah, thank you guys.